Alright, what's up everybody? This is a lesson for 1.3. 1.3 is on two topics. We got what's called a midpoint, and then also determining distance between 2 points. You probably have worked with this in the past, but it's just really important that we get this nailed down for this chapter. So we have two vocab words, midpoint and a segment bisector. First vocab word is a midpoint. Midpoint right here, it says the point on the segment that divides the segment into two congruent segments. So all it is if you look at a segment like this, midpoint is just a point that divides the segment into two equal parts. So that midpoint just divides this part and this part into being the same, making them congruent. Alright, so that's what a midpoint is. We'll come up with a formula on how to find the midpoint. Next, a segment bisector. That just means a segment, line, or plane that intersects a segment at its midpoint. So that's if you have a segment, I'll draw it out again down here. So if you have a segment, and then you have another segment that kind of cuts through that segment and creates two congruent segments. That's what we call a segment bisector. Alright, this segment here cut this one into two equal parts. Alright, that's what we call a segment bisector. In this case, the one that I drew right here, DC, or this line, will be the segment bisector between A and B. Let me do that. Alright, so that's vocab words. We'll go down now to examples. There we go. Alright, so this is important right here, distance formula. Make sure you copy that down in your notes. Well, it should already be written, but that's important that we'll use that a lot today. Alright, so our first example is we have to use this number line to find CD. All that is, what's the distance between this point and this point. All you would have to do is you could just take the higher number, 4, and subtract the smaller number. Alright, so you go 4 minus, this is at -5, so you can go 4 minus the -5. And remember, whenever you subtract the negative, you're really just adding, so 4 plus 5 would be 9. So that's the distance between those. Yeah, remember, distance can never be negative. You kind of get like a distance of -9. Doesn't work like that. It has to always be positive. Alright, next example. It says find the distance between point R and S. R is at 5, 1. Right there. And then S is at -3, -3. So right there. Alright, so we got to find the distance between those 2 points. R and S. Alright, so there's two ways to find this. The first is by finding it using the Pythagorean theorem. Let me just draw the line here. If you remember Pythagorean theorem, that just means if you have a right triangle like this, we take this side squared plus this side squared, it equals that bigger side squared. So that's what we'll start with. So if we were to make this line here, the one that we're trying to find the distance for, if we made that a hypotenuse, we could actually figure out what's the distance between this point and this point to figure out one side of the triangle, which is 4, and then what's the distance between S and that corner point. That would give us the other side of that triangle, which that would be 8. So using Pythagorean's theorem, we could go 8 squared plus 4 squared equals C squared. C in this case is that distance right there. So 8 squared is 64, 4 squared is 16. We get an answer of 64 plus 16 would give us 80. So we get C squared equals 80. Then remember, you got to take the square root of both sides to get an answer of 80. Sorry, square root of 80. So that's one way to find it. That's using the Pythagorean theorem. So that's one way. The other way to find the distance between 2 points is use the distance formula, like it's written right there, that circle up there. Alright, so I am just going to copy that down again. We got d equals x2 minus x1 squared plus y2 minus y1 squared, and the square root of all that. Alright, so our 2 points are just right here. I'm going to make this point number 1, this point number 2. So x2 would be negative 3, x1 is 5, so we're just plugging in values. And y2 is negative 3, and y1 is just 1. And we're taking the square root of that side. That's going to give us the distance. So negative 3 minus 5 will give us negative 8. And then negative 3 minus 1 gives us a negative 4. And so negative 8 squared is just a positive 64. Negative 4 squared is just a positive 16. Combine those and we get square root of 8. Square root of 80. You notice that's the same exact answer. Alright, these two. So both those ways work. You can either find it using the Pythagorean theorem, making a triangle of the 2 points, or you can use that distance formula. That's probably the better way to do it. It goes a lot quicker. Next, we have what's called the midpoint. Remember, the midpoint's the point between 2 points. We call it midpoint. Formula is just x1 plus x2 divided by 2, and y1 plus y2 divided by 2. It's just coordinates. Sorry, it's just an ordered pair. Alright, that's really what it is. So, example 3 says find the coordinates of M, the midpoint of JK for that point J and K. All we got to do is take these points and plug it into that equation right there. So we're going to go x1, which is negative 1, plus x2. x2 is 6, divided by 2. And then y1 is 2, y2 is 1. Combine that, negative 1 plus 6 gives us 5 halves, and then 2 plus 1 is 3. So we get our midpoint of that. You can either write your answer as a fraction there, or you can make it a decimal. 2.5 for x and 1.5 for y will give you that midpoint. Alright, next it says find the measure of BC right here if B is the midpoint of AC. Alright, so if you look at this picture, it tells us B is the midpoint of AC. What that means is this side and this side are the exact same. They're congruent. Alright, so if I know they are congruent, it means I can set them equal to each other to solve for x. Alright, so that's what I'm going to do. I'm going to do 4x minus 5 equals 11 plus 2x. Just saying them equal to each other. And since we only have one variable, that means we can solve. So I'm going to subtract 2x from both sides to get 2x minus 5 equals 11. If we add 5 to both sides, we get 2x equals 16. And then we divide both sides by 2 to get x equals 8. So that tells us x equals 8. But that's not what the question is asking. The question is asking what's the measure of BC. So all you need to do is plug in an 8 for 2 right there. Alright, so we get 11 plus 2 times 8. 11 plus 2 times 8, 2 times 8 is 16. So 11 plus 16, so we get our answer 27. So that'd be the distance for BC. Alright, and then just as an example, segment bisector, that'd be like if we had a point right here, D, went through here. DB would be a segment bisector of the AC. Alright, that's just an example. Alright, so that is 1.3. If you have any questions, let us know. Peace.